I want to do a little review today on graphing lines and kind of take it for another step in another direction today. Again, when we graph lines, we have an equation because it has an equal sign. And everything it has two variables, an x and a y typically, where x is the horizontal and y is the vertical. An independent variable and the y is the dependent variable. And the power on both the variables has to be 1. It has to be a first order equation. And again, we should be familiar that we're allowed to pick x. We look at the equation and say, can I pick x? And the answer here is yes. And remind ourselves, if it's x equals 7, you couldn't always be 7. In this case, it doesn't say x equals, it says y equals some stuff. So you can pick x. And I have a rational coefficient. So again, we remember some rules we had, that we can always pick 0, and then picking multiples of the denominator helps us get points more quickly. And again, I like to pick 3 points so that when I plot the dots, I know they all lie on a collinear line. They all lie on the same line. So I know I didn't make any mistakes. You only need 2 points to make a line, but 3 will make sure you're right. So I plug 0 in for x. And when I plug 0 in for x, I get -3 for y. So I have the ordered pair 0, -3, which I plotted here. The next x value I picked was 2. 1/2 times 2 is 1. 1 minus 3 is -2. 2 -2 is plotted here in the second dot. And finally, I picked x is 4. So 1/2 times 4 is 2. 2 minus 3 is -1. 4, -1. And again, we talked about this. With lines, there are patterns. You notice x went up 2, x went up 2. Y went up 1, y went up 1. We can make sure we're getting the correct pattern here also from the ordered pair. And we plot the line, and there it is. That is the representation. And again, if I was curious, I could read a point off the graph. If I take it right here, I can see that this point with the x I marked is -2, -4. If I wanted to make sure I graphed the line right, I could check that point. When x is -2, y must be -4. Plug it in the original equation right here. -4 equals 1/2 times -2 minus 3. And this is a question, is it true? -4 equals -1 minus 3. -4 equals -4. Boom. I know I've done this line correctly. Again, this should seem like stuff we've been doing. But I want to work on this equation some more, and I'm going to show that equation in the graph. This is what we have. We have y equals 1/2 x minus 3, and I have that line. I want to be clear that I can do anything I want. So if I treat this as y equals 1/2 x minus 3, I can multiply both sides by 2. And you shouldn't want to do this. I want to show you something we're doing. And I want to prove to you that I can do anything I want as long as I do both sides. I get 2y, and when I distribute over here, 2 times 1/2 is 1. So I get x, and I get -6. And then I can move the x to the other side by subtracting x on both sides. These cancel, and I get -6 on the right. 2y and -x are not like terms, so I'll write it as -x plus 2y. I have done nothing to break rules. So when we see an equation that looks like this, it is also a line. It is still the line on the graph. But when we have it in this format, we don't want it in the general format like this. We want it in the slope-intercept format. So it comes down to the simple rule. When we're given an equation to graph in its first order, we always want to solve for the y variable. So with that said, let's do it. Let's do a different line. It's a line. It's an equation. It equals -9. It has a y. It has an x. And before you say, can I pick x, you got to say, hey, I have to, step 1, solve for y. We always want to solve for the dependent variable. So I'm going to solve for y, and that's why we've been practicing those skills. First thing is to get that term by itself, so I'll subtract 2x on both sides. I get -3y equals, -9 and -2x are not like terms. we always write the variable first. I have to get rid of negative 3. If I divide 1, I must divide all terms, 3 terms, and I get y equals, negative negative is a positive 2/3 x, negative negative is a positive 3. Now I have this equation, which is the same as that. So I have y equals 2/3 x plus 3. And if I take that then, y equals 2/3 x plus 3, I can create the table. And again, I can pick the independent variables of x this time, substitute them in the equations, get the resulting dependent variable y, check the 0, 3, 3, 5, 6, 7, the x jumps 3, the y jumps 2. I can plot those points and end up with a graph. So the only thing we're adding to this is that if we get the equation in general form, we want to solve for y and make it the slope-intercept form. So again, when you have an equation like this, we want to solve for y. So I look at this and I say, hey, I want to solve for y. I got to get that term, which has the y in together. And I should probably mention, four x minus 5y equals 10. Was it 10? Yeah. I don't have to have it all be, I mean, I could have 2x plus 2x minus 8y equals 10 minus 3y. Again, this is still first order because it has only 2 variables and it's an equation, all one. We would have to gather this all on one side first. Again, bring the 3y over, these will cancel, I'll get the 10 come down, negative 8y plus 3y is 5y. 2x plus 2x would make 4x. And again, just the same steps as we've used to solve other multivariable equations. Now, if I want to solve for y, so I can graph this, I want to solve for the dependent variable. I'll solve for negative 5y first. Negative 5y equals, well, not like terms, write the variable first, negative 4x, positive 10, look left for signs, divide all terms by the coefficient on the y, and I get y equals positive 4/5 x minus 2. Alright, so let's use y equals 4/5 x minus 2. And there it is. And again, can I pick x? The answer is yes. And again, we've been practicing this. I am going to pick 0, but I'm not going to pick 5 and 10. I'm going to pick negative 5, 0, and 5, which are around the origin, which are a little easier to graph. I'm going to plug those x values in the equation and get the resulting y values. And again, you can pause the video and look at the charts, make sure you understand it. And again, I'm going to double check myself on the points. Negative 5, negative 6, 0, negative 2, and 5, 2. Jump 5, okay. Up 4, up 4. And again, if I graph those points on there, we have a line. And those 3 points were collinear. So when we have any first order equation, and remember this came from the equation (4x minus 5y equals 10). First thing you want to do with the general form is get it into our slope-intercept form. Solving the equation for y first.